Welcome back to Chuck's Laboratory. We have a couple of things we're going to look at today. This is a very special day for us. We'll get to that in a moment. But a quick update here on the shield we've developed for the cat-chasing robot. Well, the main priority here was to get some status LED updates and also to build in a potentiometer. We'll just demonstrate what it's doing here, but basically we have a 74595 that's outputting three LEDs here, just on-off LEDs, and then this is a RGB LED and it's using another 3 bits on the 74595 to drive the RGB values here. We can control the RGB values just by turning the potentiometer. This isn't actually what the potentiometer is going to be used for. The potentiometer will have two functions. Potentiometer will be used to fine-tune where dead center is on the servo. So when the servo is pointing forward at 0 degrees, but it's not actually 0, we'll use the potentiometer to tweak it a little bit to make sure it's always pointing the front direction, and also to fine-tune the steering, because this robot does not have any kind of encoding, wheel movement encoding. We're just going to be trusting that the motors get us going in the right direction, a straight line all the time, but we can adjust the left and right a little bit here, so one side or the other powers a little bit more than the other, and that should help us be able to fine-tune the robot so it goes in a straight line, and also keeps the servo here at 0 degrees pointing straight ahead. So that's the potentiometer. The LED is going to be used as basically like a range detection or a range finder. As objects get closer to the robot, the color will go through the color of the LEDs that are able to create here. Now with the 7 bits, or with the 3 bits, we can only create 7 values plus off. So we're kind of just going off the values of the rainbow, so it'll be like purple down to an orange and then to a red when something is very close to the robot. So we'll demonstrate that how that works a little bit later once we get the board put back into the cat chasing robot. But for now we have something else we're going to celebrate. It's the 88th subscriber unboxing celebration video. That's right, we have 88 subscribers. Thanks a lot to the 88th subscriber, whoever you are. This video is dedicated to you. Well, let's get underway with our unboxing. And we have here, very appropriately, the Adwater and Stir Altair-Duino 8800. This is a kit that I wasn't even really looking for. I originally was only looking for something to have blinking lights on my desk, and one thing led to another, and I discovered the Altair-Duino 8800, which I kind of always wanted, but now they're just too impossibly hard and cost prohibitive to own. But this should give us a pretty good idea of what it would be like to have an Altair back in the day. Now, I didn't get a chance to play with Altairs when they were new. I was in the Commodore side, so the closest I got to something like this was the Kim 1, a single board computer. So this even is an upgrade from the Kim 1, actually. So this actually has more than one LED, but it doesn't have a display. You know, the Kim 1 did have a display and a keyboard, I will give it that. Well, let's go ahead and unpack our You Build It Altair-Duino 8800. I already peeled out all the foam because, you know, foam. What do we have here? Something in a box. That is a power supply, and it does have the US connection. That's fantastic. Yeah, nice pack of LEDs. I dig it. Now, kind of a side story here. I was going through some of my old electronics and came across this set of 2 LEDs, red LEDs from Radio Shack. I think I know the project this was from, so I think that puts us as around 1991, maybe 1989, somewhere between those 2 years. So I was going to unpack these and have these on backup, but this is kind of too cool. I think I'm just going to keep it in the pack, and we'll keep it on hand for maybe for special occasions. All right, back to the Altair-Duino. Looks like a bunch of headers. Here are some of the switches. I think some of the switches are different functions, so I don't think that's all of them. Looks like we have 15-pin DIN. Is that VGA? A USB. I'm gonna get my glasses. Alright, we are back. Alright, got a little memory card here. Serial interfaces, looks like. So I assume this is all like a serial board. Here's the Arduino Do board. This is pretty amazing that it comes with the actual Arduino Do along with everything else here. That makes this an incredibly high value kit. I'm really impressed. I wasn't sure it was going to come with that, to be honest. The serial, okay, this would be like the serial extension from the board out to the outside world. Some logic chips. Not sure exactly what these are, so we'll have to dig into that later. Nice standoffs. Serial connector. Missed some foam. Oh, look at this. We have a fix we have to do here. What do we have? Oh, looks like we have to add an extra wire as part of the assembly. And here's our book. It's actually a pretty decent book. Looks like it's got lots of good photos, but I don't know if you can tell from the camera shot here. Looks like the printer was running low on ink. That's fine. Still completely legible. The main goal of building the shield that we had there for the cat chasing robot with the LEDs and potentiometers was really kind of soldering practice for this kit. So I think I might need a little more soldering practice before I get into this, actually. This is actually metal. Interesting. Nice and sturdy, anyway. Looks like here's the outside of the case. This also is metal. This is sturdy. Like, it's actually a really sturdy piece of the frame here. I'm amazed. That's going to make this really nice and sturdy on the desk, but it might make it a little bit trickier to mount on the wall. Looks like we have our circuit board here. I don't think we're going to have too many problems soldering in here. It looks like the headers themselves are going to be the trickiest solder. You do have some of the integrated circuits here. Those will be the switches. And here we go. Here's our front plate. That is pretty cool. Altair 8800 computer from MITS. It's really quite thick, sturdy. It looks beautiful. Oh, the decal's already included and already attached too, which is pretty cool. What do we have here? And a clear acrylic backplane with the access ports for the I/O. Put this back down, face down. Circuit board back in. Target frame. All right, well that's pretty amazing. I'm amazed at the value that I have out of this kit here. I can't wait to start putting it together. We're not going to do too many videos of the assembly, as it's tricky enough for me to get enough time to do work on it, let alone put together videos as we're doing it. But we'll probably do like maybe a 2-video series, maybe 3 along the way, maybe like a first construction, first test, and then first software. We do have a couple of programs that we want to run on this very specifically. We're going to do some playing with CPM's, what is it, VisiCalc? I forget which spreadsheet it came with, but there's a spreadsheet that comes with the CPM part of the Altair-Duino that lets you do self-referencing. I've actually got an application for that exact thing, so I'm going to try setting that spreadsheet up in CPM, and that'll be kind of fun. That's for Kerbal Space Program. And also want to play a little bit of the old school Star Trek. I remember playing that game back in the 1970s. I'm pretty eager to try it again here. I was terrible at it then, and we'll see if I'm any better at it now. Thanks a lot for joining as we unpack our Altair-Duino, and thanks a lot for 88 subscribers and getting us here in Chuck's laboratory. Normally we'd have cats down here, but they're all asleep right now. Well, if you made it this far, thanks a lot for keeping on board with the bonus footage. This is the the shield that was built for the cat chasing robot here with the 74595. What we're actually having a part for is because we need to disassemble or otherwise bypass the system LED here. So unfortunately the system LED was going very crazy because the system LED is on pin 13, which actually is the same pin that the ultrasonic sensor is connected to. So by system LED, we're going to put this back in here and demonstrate how the range LED works on the 74595. We can demonstrate how the green and red work. There's green, and when it's in basically stop mode, the red light comes on. There's basically toggling the modes on and off. And then as we get closer, the light color changes. So this is helpful for understanding both whether or not the ultrasonic sensor is working, and also some kind of visual feedback to see what range it's detecting. You have the range being triggered at 5 centimeters, so anything closer than 5 centimeters, it goes into its red mode. Thanks a lot for joining for the bonus content on the 88 subscriber video, and we will have a 128 subscriber special as well. So let me give you a hint as to what the 128 subscriber video might be about. Have an awesome day.